So this is in your 3A homework packet. It's called 3.A.7 Worksheet Factoring Quadratic Equations. Originally it was intended for after the quiz, but today we're going to go through it as just like a quick little recap on how to factor, because this was all from Unit 2D, and you had that on your Unit 2 test, 2E test. So we'll go through a couple of these that we've circled. The rest are just more practice that you can do. And in addition to that, you'll have a worksheet that will be passed out that it's called 3.B.0, which is getting us ready for the factoring that we'll need with polynomials, which is coming up Monday. So we've been graphing polynomials in standard form in intercept form. Now we're going to move on to how to graph them in standard form next week. Okay, so just to do a recap with factoring, the main idea is you always ask yourself, is there a GCF whenever you start any factoring question, any quadratic, and notice that all of these ones here on this page, especially the ones that we've circled, are all not equal to 0. They're just expressions. There's no equation here. It's just an expression because there's no equal sign. So when you see that, you will not solve these. You will leave them as factors. You're going to leave them with parentheses, and that's when you'll know you're done. So whenever you start this, again, your first question is always, is there a GCF? On every single one of these. Sometimes there will be, sometimes there won't. I'm actually going to start with number 3 because it's the one that kind of looks different from the others. And so number 3 here does have a GCF. And you would say, what is the GCF between 14x squared and 7x? And to figure this out, you would figure out the factors of each one. 7 does go into both of those. And x also does because it's common to both terms. You always take the least number of x's between the two. And so as soon as we figure that out, we can write it in front with a parentheses after it. And then if you want to actually divide them, it helps to have this division, because that's what factoring is essentially. We are dividing and leaving the factor in front of it. So 14 divided by 7 is 2. And for these x's, we had 2 x's, and we're taking 1 away from there. We're dividing by one of them, so we have just an x left. Then for 7x, divide by 7x. Now those will technically cancel, but you need a placeholder. You need to put a 1, so it's just 2x plus 1. This is actually the final answer. Can't go any further at this point because you took out the GCF, you saw what was left over, and now there's no quadratics. So when there's no quadratics left to try to factor, we're done. So that was number 3, because it was just GCF. When you notice it's got 2 terms instead of 3 like we're used to seeing, then most likely it's going to be this special kind where you start by taking the GCF out and then you're done. Now number 2 also has 2 terms up here, and so we'll look at that also, in addition to the other 2 are a little bit different because they still have more factoring to them. So for number 2, this is an example of dots, difference of 2 squares. Now it can be done the same way as how we're going to do numbers 1 and 5, but the quickest, kind of easiest way to do this is to make yourself 2 sets of parentheses like this, and to take the square root of each of those terms. So you would say, what's the square root of 9 and what's the square root of 25? Well, the square root of 9 would be 3. And the square root of 25 is 5. And just like how you can notice the position of each of those numbers, the 25's on the end, so the 5's come on the ends of the parentheses, and the 3 goes in the front of the parentheses. Now remember, don't forget x's along with the 3's, because this was 9x squared, so you still need to get to that x squared. And the reason why this ends up being only 2 terms instead of 3 is because the middle term cancels out when you have one that's a plus sign and one that's a minus sign. It does not matter which one you put where, but this is how we do dots, or difference of 2 squares. And again, it makes your life so much easier if you can identify that those are perfect squares. If you kind of just start memorizing all of the perfect squares from 1 to 100 at least, that would help to identify them quickly, something like 9 and 25. And you'll see lots of different types of numbers with those. All right, then we come back to number 1, and let's try this one. And so the idea is, again, ask yourself if there's a GCF. There wasn't a number 2. 9 and 25 had nothing in common. But this next one, number 1, does have something in common. All 3 of those terms have a negative 2 in common. So when we see that, you take the negative 2 and put it in front, and you're dividing every single thing by negative 2. you're just factoring it out by dividing it like this just to see what's left over. So the negative 2's cancel on the first term, leaving me just with an x squared. Negative 18x divided by negative 2 is going to be a plus 9x. And negative 40 divided by negative 2 would be a plus 20. And then from there, you would try to factor this further. So we take that x and we fill it in. So you would have 20 on the top of the x, because it's always the last number times whatever is in the front if there was a number in front of x squared, which there's not. This 9 goes on the bottom, which is the middle term. So it's thinking about two numbers that multiply to give me 20, but add to give me 9. And so those two numbers would be 4 and 5. And then as soon as you figured out those two numbers, you decide if you need the box. Since there's no number in front of x squared, we go right to these two parentheses, bring the negative 2 down as well. You don't want to lose that negative 2. And you want to write what your two factors are using the numbers you just came up with in your x. So it's x plus 4 and x plus 5. And then you're done again. We're not solving this, we're just factoring. So that's how we do those top three so far. If you have questions with these, you can always bring them on Monday too, and we can go through how to figure out, whichever ones you have questions on. All right, number 5 on the bottom here. We have, looks similar to number 1 in that it has like a number in front of x squared. The main difference though is that when I start to do this problem, there's no GCF. Okay, so I can't make it simpler by using a GCF. Instead, I go right to my x. So I start by multiplying the first number times my last number, and I get negative 20. The 19 goes on the bottom because that's my middle term. And I'm thinking of what two numbers multiply to give me negative 20, but add to give me 19. And so that's going to be 20 and 1, but you'll make that 1 a negative. You can, of course, use the trick on the calculator, on a graphing calculator. I can show you real quick in case that helps, because if any of the factors are larger on the classwork and homework, you can, of course, get some extra help that way. So you go to your y equals, and you type in that top number, negative 20, divided by x. And then right below it, on the next step, you write that same thing again, but this time add x. So it's negative 20 divided by x and a plus x after it. Then you go to your table by pressing second graph, and you see in this column here, you're looking for that 19, not negative 19 like this one says. So you want to keep going down until hopefully we see 19. Or actually, we want to go into, yep, it looks like it'll get there. Right here. There's positive 19, and the two factors then are the negative 1 and the 20. These two numbers are the two numbers that we came up with, because again, that third row made it 19. Okay, so then from here, we know what the factors are, but we can't go right to the parentheses. We need that table or that box. And so we start by putting the first term in the first spot. Then we have in the bottom right corner that negative 5. And then we have our last two terms here in this diagonal are the two numbers you just figured out, 20x and negative 1x. And you can put those in either order. Okay, now at this point, we start with GCFs. So you take the first row and you take out a 4x, because 4 was common to both, and so was the lowest number of x's. Then for the rest of these, you can either keep doing columns and rows of GCFs, or 4x times what number here, or what term here, will get 4x squared. And so we just need an x. That's all they have in common anyways. And 4 times 5 is 20, and there's that x there. So this tells me it is x plus 5. The bottom row here has a negative for that first term, so whenever that first term is a negative, you look at the number 2, and there's no GCF between the two numbers, but it is just a negative 1. And you can double check that the first and the last numbers, 5 times negative 1, do give you that negative 5. We write them out in two parentheses like this, and we're done. So it's 4x minus 1 and x plus 5, whichever order of parentheses goes first or second doesn't matter, but make sure what's inside the parentheses are the same. So you do have to have a minus 1 with 4x and a plus 5 with the x. Okay, and then that was pretty much it, but we wanted to add one more kind of question, which it said solve. There was none on this worksheet here, but the homework in the 3.B.0 worksheet that you're going to have in just a couple of minutes does have a section of just factoring, and then it has a section for solving. And so I kind of ignore this part. Let me do it right here on this right side. I'm going to rewrite this. It is, let's solve x squared plus 7x plus 4 equals negative 2. And we'll kind of fit it in right here, hopefully, if you want to do the same in yours, just so that you have this example to look at. So the first thing you always do when you're solving is try to move everything to one side. Wherever the x squared is positive, that's usually the side it's helpful to move stuff to. So I'm going to add 2 to both sides. And now I'm looking at x squared plus 7x plus 6 equals 0. And now is where, when something is equal to 0, you're going to get solutions for it. So we start with the x. You have 6 on the top, 7 on the bottom. Your two numbers that multiply to get to 6, but add to get to 7 are 6 and 1. Both positive 6 and positive 1. And then from there, you go to your two parentheses, x plus 6, x plus 1. But this time, you don't stop right here. Because it's equaling to 0, you have to set both factors equal to 0 using the zero product property, the ZPP that we brought up before. And when you set them both equal to 0, you're just going to get their opposite answers. I know I don't have much room here. You're subtracting 6 on this one and subtracting 1 on the other one. So your two answers are x equals 6 and x equals negative 1. I'm sorry, x equals negative 6 and x equals negative 1. They're both negative answers. And that's it for what we're going through here. The rest of the time you can take to work on your 3.B.0 worksheet. There's a front and a back to it, and then whatever you don't finish is homework.